everybody, I'm Miss Cooksey, and today we are going to be talking about proofs using the segment addition postulate. So we're going to be looking at line segments and we're going to be proving different relationships between line segments because of some different theorems and postulates. So the first thing we need to do is we need to go through some theorems that we're going to be using today. The first theorem we're going to be using is the midpoint theorem, which says that if M is the midpoint of AB, then AM is congruent to MB. So this means if I have M as a midpoint, then the two segments on either side are going to be congruent. Midpoint means exactly in the middle. So if it's the point exactly in the middle of a segment, then the two segments on either side are congruent. The congruence theorem for segments says that if two segments are congruent, then the lengths are equal to each other. So this is defining congruence to say that congruence means that segments are equal. The congruence theorem for angles says that if two angles are congruent, then the measures, that's what this M means, it means measures of the angles are equal to each other. So if the angles are congruent, they're the same number of degrees. If the segments are congruent, they're the same length. We need that definition so that we know what congruence means. There's three more postulate or properties that we're going to learn about. We talked about these yesterday with algebraic proofs. The transitive property says if A equals B and B equals C, then A equals C. So if two things are equal, then the things on the end are equal to each other. The reflexive property says everything is equal to itself, or AB equals AB. And the symmetric property says that it doesn't matter which order on the equal sign we place things, they're still equal. So if AB equals CD, then CD equals AB. Next, we're going to practice. So I want you to go ahead and pause this video, and I want you to see if you can match each statement to the reason from these choices above that you believe the statements match. Go ahead and pause. Welcome back. Let's see how we did. So the first, if AB is congruent to CD, then AB equals CD. That is the definition of congruent segments. Next, we have if JK equals KL and KL equals LM, then JK equals LM. That's the transitive property. Since D is the midpoint of CE, then CD is congruent to DE. That's the midpoint theorem. Then we have the symmetric property, the definition of congruent angles, and the reflexive property. We are going to use all these properties as we move into proofs. So, like I said at the top of this video, each of the proofs we're going to do in this video uses the segment addition postulate, which means if A, B, and C are collinear, if they're on the same line, then point B is between A and C if and only if AB plus BC equals AC. In layman's terms, this means that one tiny part of the segment plus another part of the segment equals the whole segment. We're adding the two small parts to equal the whole. So let's see this in practice. Here's the first proof we're going to do. AB is congruent to DE. So AB is congruent to DE. BC is congruent to EF. BC is congruent to EF. We want to prove that AC is congruent to DF. Let's do that. Our proof always starts with our given. So we are going to rewrite the given information. AB is congruent to DE and BC is congruent to EF. In order to manipulate this a little bit, we need to change this to the length of the segment. That helps us add and subtract. So we're going to use the definition of congruent segments to now say that AB is equal to DE and BC is equal to EF. We need to have this in equal sign format so that we can use the segment addition postulate. Next, we are going to write the segment addition postulate. So AB plus BC equals AC, and DE plus EF equals DF. So we are just stating that the two small parts equal the whole part, and the two small parts equal the whole part. That's the segment addition postulate. Now, to continue on with our proof, we are going to substitute. So if AB equals DE, we're going to replace this DE with AB. And if BC equals EF, we're going to replace this EF with BC. By doing those replacements, we get AB plus BC equals DF. That's substitution. Now we're going to substitute again. This time, we know that AB plus BC equals AC, so we're going to substitute AB plus BC with AC. That's also substitution. Now we can get to the end of our proof and use the definition of congruent segments to prove that the two segments are congruent. We have reached our proof statement. Let's do one more example together, and then you're going to try 2 examples on your own. So here we have AC is congruent to BD. So AC is congruent to BD. We want to prove that AB is congruent to CD. So we always start with our given. And again, in order to manipulate this, we need to make this into an equal sign. So now we're going to use the definition of congruent segments. So say that AC is equal to BD. Next up, we are going to use the segment addition postulate. So we're going to break AC up into its parts, and we're going to break BD up into its parts. So AB plus BC equals AC, and BC plus CD equals BD. Because AC equals BD, we can substitute these 2 expressions in using substitution. So we can say that we replaced AC and BD here with AB plus BC for AC and BC plus CD for BD. Once we substitute, we're going to use the subtraction property of equality and actually subtract BC from both sides of the equal sign, leaving us with AB equals CD. The definition of congruent segments gets us to our last step, and we have proved that AB is congruent to CD. The goal of a proof is just to make sure that you have justification for every single thing you do. Even if it seems like common sense, you still need justification. Here are our next 2 proofs. I want you to pause the video using your guided notes. Go ahead and see if you can prove these next 2 proofs. Welcome back. I'm going to show you what the correct answers are. Pause this video and check your answers for proof 1. Welcome back. Pause the video and check your answers for proof 2. Thanks for watching. I hope this video was helpful. Make sure you subscribe so you never miss a video, and I'll see you next time.